In this tutorial we are going to look at distance time graphs, or as they are sometimes known as travel graphs. Before we even start to take information off a graph, the first thing we must do is understand the scales, because it is only when we do understand the scales we are working with that we can interpret the data on the graph. In a distance time graph, the time is always placed along the x-axis. In this example, the time represents a period from 1200 hours to 1600 hours. The distance is along the y-axis, and this represents a distance in miles from 0 miles to 11 miles. Look at this example. In this word problem, we are told Jack travelled 9 miles to a reservoir, but en route he got a puncture 30 minutes after leaving the house. On fixing the puncture, he continued to the reservoir, and finally he returned home. In the first question, we've been asked how far was Jack from his house when he got the puncture. Well, in the word problem we told he travelled for 30 minutes before stopping, and the point where he stops along the y-axis is 5 miles. So 30 minutes after he had started his journey, Jack stopped 5 miles from leaving his house. In a distance time graph, a diagonal line indicates movement, and this line indicates that Jack travelled 5 miles in 30 minutes, whereas a horizontal line indicates being stationary. In the second question, we have been asked what was Jack's speed between fixing the puncture and arriving at the reservoir. Well, this is the point at which Jack fixed the puncture and moved off again, and this is the point where Jack arrived at the reservoir. To calculate the speed of travel, we use this equation. Speed equals the distance travelled over the time taken to travel. In the period from fixing the puncture and arriving at the reservoir, Jack travelled 4 miles, and the time it took him to travel these 4 miles was 1 hour. So Jack's speed was 4 miles per hour between fixing the puncture and arriving at the reservoir. In the third question, we've been asked how long did Jack spend at the reservoir. Well, this is the point where Jack arrived at the reservoir, and this is the point where Jack left the reservoir. Reading the time from the x-axis, we can see he arrived at 1400 hours and left at 1700 hours. So the time he spent at the reservoir was 3 hours. In our final question, we have been asked what was Jack's speed between leaving the reservoir and arriving at his house. Again, we use the speed equals distance time formula. The distance is 9 miles and the time taken was 1 hour. So the Jack's speed between leaving the reservoir and arriving at his house was 9 miles per hour. We'll just review what we have covered here. Before we read any graph, make sure you know and understand what the scales refer to, because it is only when we understand the scales being used can we interpret the information in the graph. In a distance time graph, the time is always placed along the x-axis, and a diagonal line indicates movement, and a horizontal line indicates being stationary. To calculate the speed of a body over a period of time, we find the gradient of the line, and this is given as speed equals distance over time. We should also note that this formula can be transposed to give it in terms of time or distance. For example, time equals the distance travelled divided by the speed taken to travel that distance, and the distance a body travels at is equivalent to the speed that body is travelling at and the time spent travelling at that speed.